Hello, everyone. Welcome and thanks for joining us. There's a lot of people from different time zones, so I appreciate some of you making the effort to wake up early or stay up till late. Um, and hope this is a good session at the end where we will have some live Q&A with Peter Yang. He's the product manager for our scanning products in Tersus GNSS. And myself, I am the Director of Solutions in Tersus GNSS. We're specializing in GNSS, as our name says, but our new product line, the MVP S2, S1, and MVPStudio, now is completing our capture reality capture products. So MVPStudio is a new software that we have just launched, and we would like to display it and share it with different regions, different industries, and get their thoughts. Because we're very excited about some of the features that we've built, and yeah, we'd like to see what you all think. So I'll start with just a bit of housekeeping. So we'll keep everyone on mute during the presentation, and afterwards we'll have 20 minutes for Q&A. So we'll start in a few minutes. We'll do a 30-minute presentation taking you through the software, some of the basic features for point clouds that we've made available for our equipment, and any laser scanning LiDAR equipment. Then we'll go into some live demonstration with Peter, who can run the software and show you some features live if you have some questions, and just general questions about the ecosystem as well. All right, so we also have the chat. If you have any questions there, feel free to drop them as we go along. We have some of our engineers that are keeping track of the questions, and we'll gather them all, and at the end, we'll try to answer them all as well. So the meeting today is being recorded also, so keep that in mind. You can see it later, share it with your colleagues. Or if you don't have time to answer all the questions, we'll get back to you by email. We'll send you the review of this session and all of the attachments that we'll go through today. All right, so today we'll go through, seems like a large list of features from MVPStudio, but they're all gathered in 3 different modules. So the first is the project section, which is importing MVPS1 data, processing, viewing the project, and then viewing any point cloud data in the environment, making measurements on the cloud and the image. Those are the basic viewing tools. Later we'll go through some of the basic tools for any point cloud, coordinate checks and transformations between coordinate systems. General point cloud tools for clipping boundaries, surface calculations, and then some advanced tools that we've built that we're really excited about. So some automatic extraction by line tracing, automatic extraction by wall line detection, point cloud classification, registration cloud to cloud, and a new function that we call detail fusion, which is the combination of point cloud and imagery data, and the Gaussian splat module. So we'll start with the first basic feature of MVPStudio. MVPStudio is a companion to the MVPS1 scanner, and one of the basic things that it does is bring in data from the scanner. So the whole project can be imported, and all of the information that's captured on the field can be viewed and analyzed here. There is a smart health check tool that gives you a view of the RTK quality throughout the capture. It also gives you the sensor status, the inertial and other sensors throughout the capture, and can be exported as a report. So this smart diagnostic tool can give you a heads up on if there are any issues that will come up during processing. There are different modes for processing. One is the fast mode, which is just a quick processing, and high quality is the full capture. There are different scenes that can be selected for different environments. Units can be customized. We can select if we use control points or RTK, if we colorize or generate panoramas. And then for control points, we can input directly a list of control points in a text file or a CSV. We just have to be mindful of the order of the coordinates. So easting, northing, elevation in this case. These coordinates are only to reference the point. There is no coordinate reference system at the moment. We will do that later. So after the project has been processed, we can view the data. So by opening a project that has already been processed completely, we can bring in the point cloud data, the trajectory, which we see here in different colors. And the point cloud can be viewed also in different shaders. So the first one is the RGB. This one is elevation, intensity, LiDAR intensity, classification, if there is classified points here, level of detail, and time. So this is different ways to view the same data set. It doesn't change the information underlying in the data set. The X-ray mode and the EDL mode give us different ways to visualize and bring out some more details. When we go into the panorama view, we can click on any of the images that were captured during the project and then see the 360 view of the point. We can cycle between cameras. So here we go into the next camera, and we can change the transparency between the camera and the point cloud underneath. Because the point cloud is underneath and the image data is overlaid on top, we can make measurements directly on the point cloud. But we can use the visual information of the imagery which is sometimes crisper, to highlight the points and define the points. So both the panoramas and the point cloud are overlaid with enough accuracy that a point measured on the sphere is referenced to the point cloud. So this is one of the basic features, measuring on the cloud and on the image. You would think that that's basic, but a lot of softwares don't have that. We felt it's intuitive. So that's one of the major things the viewer allows you to do. So all of the measurement tools, points, distance, height, for example, if you measure height, it automatically goes vertical on the reference frame down to a point. Angle measurements, all of them can be done if the point cloud is in arbitrary coordinates. They actually don't need a coordinate reference system defined. All of these measurements are useful for regardless of the reference system that the cloud is on. But if we're measuring coordinates, the coordinates do matter. So here we're using the point capture function to add points to the cloud or to the job as if we were doing a survey. The coordinates that are saved here are the reference frame coordinates from the capture. They're not georeferenced to a datum, so you will see that the coordinates are 3, 6, 0. But these points are useful. They can be converted later, and right now we can define feature codes or attributes to the points that we want to digitize. We can define the points during the capture or after the fact. Once a cloud is georeferenced or tied to a datum, we can overlay a base map over it or under it, rather. And the point cloud can be visualized also changing the transparency and adjusting the height of the base map. By changing the transparency, we're changing between what's in the background and what's in the point cloud. So this is important, and we'll show it here. This is checkpoints. When we define checkpoints, we bring in a list of coordinates. Also, we need to be careful how we define the order of the easting northing elevation or northing easting elevation on the file. And when we bring them in, we have to select the same point on the point cloud. So it's useful if we have both the point cloud and the panorama to choose from. This checkpoint report or this checkpoint process allows us to bring in the known coordinate that we have for a job, and then visualize the actual point in the point cloud. There are always some discrepancies, some centimeter discrepancies in a capture, so that's what we want to measure. And when we correctly define the feature on the point cloud, we are getting the actual survey accuracy or the tie-in to control. That is the accuracy of the point cloud. Because the point cloud is a rigid data set, control points have some variation. It's very important to select exactly where the point is, and there will always be some RMS discrepancies or some points that go above a specified tolerance. This can be all exported into a report, and each one of the point selections can be included, and the general accuracy of the whole accuracy check can be exported there as well. So some other basic point cloud tools, apart from the measurements, are editing and clipping the area. So the clip box lets you define an area of interest. The profile lets you cut a section and define a profile of interest. This horizontal section is made up of a slice. So in 3D, you would see the slice width and the points that make up the average of the profile. Another feature we have is the ortho image. So similar to a profile, an ortho image is a horizontal plane that cuts through the point cloud at different heights and can be exported as a georeference image. So this is not an ortho photo or an ortho image like we're used to seeing in GIS, where the whole vertical surface is seen. Here it's just a slice. So it's an ortho image slice, but it is georeferenced. And for jobs that have a lot of change in elevation, this is an interesting feature to use. So surface tools are another one of the basic features that allow us to do reports for volume calculations. So for stockpiles, for cut and fill, and for progress monitoring and changes in volumes. So we start by defining an area around our stockpile of interest. We'll do a stockpile here. And the program will start calculating, and it will generate a report and the surface analysis, the analyzed surface that will be used for the report. So all of the parameters here can be changed, or the type of calculation can be changed and then recalculated. So we can run again. So instead of stockpile, we'll do cut and fill. And that generates different type of data and different reports. All of the data that is shown here can be exported as a data set or as a report. If we do another, this area is more interesting for cut and fill. So by selecting the area, notice that there's some edges around that will introduce a little bit of noise. And maybe the mesh surface is a little bit too broad for some of the features. So if we change the resolution down and recalculate, we can get a more accurate report. Yeah, so that fits, that the triangles there fit better to the features of the surface. And another way to look at it is if we see the points. So if we can display the base surface, the analyzed surface, the calculated surface, or both at the same time. And we can display the points that are used for the calculation, or the break lines and edges that are used for the calculation. So if the resolution needs to be changed, the points can tell us how it's best fitting to the surface. So we're bringing it down again in resolution, and it recalculates again. Of course, all of the tools and all of the calculations here can be exported to a report with the same format. So if there's changes in a job site week to week, the progress monitoring report can be this report can be used as a progress monitoring report. Also, we can easily generate contours. Any surface that is generated can just basically calculate different contours at different intervals and display them on and off. So now we go to some more advanced features, and we'll start by automatic extraction. And this is trying to do digitizing lines on point cloud, which has always been a difficult feature to do. So if we start seeding a guideline that defines the feature, the software automatically detects by intensity or by color or by geometry where the line feature that we're trying to digitize is, and it will go automatically digitizing. When it comes to a problem like the corner before or this curve, it will stop and ask for our help. We decide if we want to continue, we want to define it again, and it will show us also the confidence that it has in digitizing that line. So we can move that threshold up or down depending on how accurate we want the digitization to be. If there's a lot of noise, we need to be a little bit more flexible. If the line, like road marking, is well defined, it's easier to do. But if we have curves, for example, which are not well defined by intensity, we need another parameter. So the parameter for curve extraction uses geometry, and the same can be done for walls to extract automatically all of the curves along a road surface. All of this can be exported also to a DXF, and the line work lives in the same coordinate space for the project. So now let's do the same for wall lines and for indoor buildings. In this case, the environment is different. We're in a narrow or closed environment, and we can define the floor and the roof or the ceiling, and the algorithm starts detecting all of the features that are perpendicular, vertical, and defines the wall segments, the pillars, and any area that doesn't fit is flagged for review. So that information is now in the coordinate space, in the project space, and we can analyze or continue to review the proposed floor plan. So this is what a surveyor now needs to do, or a CAD person needs to do. So review the fit between the data and the digitized line work. This all, of course, depends on the quality of the captured data set. So if there's a lot of noise, if there are mirrors, it's very difficult to do, but you can see that it's very clean data in this example. So it's important to know how to capture on the field to get these results. So this architecture floor plan can be exported as a report or as a CAD floor plan. Once we review and accept all of the features that have been digitized. So this is the architectural floor plan. If there's any edits, the operator can go back to change any of the line here and review, and then re-export again. So this allows you to get very consistent and clean products very fast. All right, so we're in the process menu. We've gone through line trace and wall lines. Now let's do a classification. So any point cloud can be separated basically into the terrain and into the features that are above it. So doing a ground classification extracts all of the above ground features and then leaves only the bare earth. There are different parameters that can be set there depending on the environment that one is working on. But once the classification is done, we can view the point cloud, select the classification view, and it will show us only the classified ground points. All right, another important feature, not just for SLAM, but for any point cloud or reality capture job is registration between clouds. So we often end up with different data sets that don't match well within each other. So we wanted to bring all of the survey tools available from different software that we've got specializing in survey into the MVPStudio routine for registration. So in this registration mode, we define 2 point clouds. Here we have them separated by color, and so point pairs, so points that are visible in both clouds. And we can go into each one of the clouds, define the point in cloud 1, define the point in cloud 2. And as we go, we can see the fit. So the algorithm, as soon as we have 3 points, we will see how it's fitting. And we can align both clouds together. All of this also can be exported to a report. And then the last feature from the advanced tool menu we have is detail fusion and the 3D Gaussian splat mode. So that feature is very useful for that label detection use case, but for defining control points is very useful as well. So a lot of times you don't have enough resolution or contrast in the point cloud to see the marks accurately. but if you can define the area in the image, it sticks out very clearly. So this is an easier way to define the control points. And another engine that we have is the 3D Gaussian splat visualizer. So this is MVPS1 data also. So the camera data was just processed in a different way in the 3D Gaussian splat engine. And the viewer here allows us to move around and orbit and fly through the splat. So also this is in the same coordinate space that the point cloud and the panel spheres are. This is another data set for a different job though. So this was a bigger and more complicated environment, and you can see still the quality of the Gaussian splatting is pretty it's pretty clean. There are some noise features around there from people standing, but this can be improved still. So one of the differences between Gaussian splatting and the point cloud and panel spheres is that Gaussian splats traditionally don't have any coordinates behind them. But that is what we are working on, and that is the vision that we have for MVPStudio, combining all of the different capabilities of SLAM scanners and point clouds into a single ecosystem and a single software. So that was our showcase of the features and the advantages of MVPStudio. We have Peter running MVPStudio with that same data set. We will make it available also for you guys. So you can download the software, the data set, and explore it on your own. But if you have any questions, we can start to organize the Q&A session. And Peter, do you want to say something?
Yeah, hello everyone. I'm very happy we just delivered the new software MVPStudio, and currently it's quite good. And the feedback from a lot of customer, we are very thank you for all the dealers before we final released. They do a lot of test job for us. It's really useful, and we enhanced a lot. And actually, this software just the start, and the developing speed is really fast. And I also believe in the future, for example, we can work with a lot of dealer or a lot of end user, and you have any suggestions, just give us the feedback. And I believe it will get more and more function, and we enhanced very quickly. And also, I'm really happy to answer a lot of questions. If you have some function recommendation, or you have some question about the software, and I can also do some small demonstration here. Yeah.
I see several questions have been answered already in the chat.
Yes.
But if anyone has a question, they can raise their hand in Zoom here.
I'm really happy to share some data from my side. So, all right, everyone can see my screen?
Yes.
Yeah, okay, good. Yeah, from for example, from this data, we will show a lot of new features, and we have a terrain land trace. Land trace function is most popular function recently, and we also improved a lot for the algorithm. So I will introduce more about this function. For example, you can adjust the smoothing here, and you can just need to click here to start a line, and then the AI will assist you to automatically draw the line for you. Yeah, so you can see the line is keep growing automatically. And you can, anytime you can finish line directly from here. 可以吗？ And
Take
also,
the screen share.
yeah.
Go ahead, sorry.
The screen is okay?
It's a little bit slow for me, so it doesn't do it justice to show how smooth
Okay,
it really
no
looks.
worry.
But
Yeah.
it does show the progress of the line tracing.
Yes. And also, currently we work more features. For example, like detail fusion function, pie inspection, and the forest function, and also sound analyze function. So we all believe this new function can help a lot of customers, and we also discuss with our customers' need. For example, the sound analyze. If your data have the location, it will show the real-time sound shadow analyze for your building, or for the forest, for analyze and for report. And you can even adjust anytime in a year, adjust here. Yeah, adjust the time anytime in the year to adjust the shadow. It display. And you can also compute the hour of the sunlight. And also see how sounds going from one day in one day. Yeah, that's a lot of new function, and we all believe it's really useful. And also we do a lot of small jobs for some customer as what they want. For example, some customer want to extract the piles here. So we have the pile inspection function, just really easy for this kind of use. For example, this customer need the angle of this pie, need to analyze the angle automatically from point cloud. So we currently we make the special function for the customer, and it will get the and automatically analyze for each pie, and you're able to get a report. So this is like we cooperate with our customer and do some special functions, and to help the customer to analyze the point cloud and get a better result. And you can even use the polygon to circle the pie and run automatically inspection.
Peter, we've
Yeah.
got one question in the group.
Yes.
From Shahid. Hello?
Yes.
You're unmuted, Shahid, but we can't hear you. Maybe you can type the question in the chat.
Yeah, you can direct the central point of the pie, and you will be able to get the report. This is some needs from the client. And for example, if you have some difficult in some special environment, you want to do some analyze. I think it's still possible for us to make the functions for special customer. For example, you are able to get a report. I will show you the report. Yeah, that's a column inspection report. You're able to see each coordinate and how we analyze the tilt angle and also the quality. It's really accurate. And before, if customer need to check by manual inspection, it's really difficult. Yeah, because it's point cloud, you always need special software to do the calculator or do the process, and even you are really hard to click that point manually. So this is a very good function for the customers, and we also believe in the future for such kind of a similar function. For example, if you want to analyze the tree, analyze the building, or do any analysis based on the point cloud, we also have the ability to make for our customer. So this is the future. Future is coming. Yeah.
Yes, there are a lot of custom requests for different industries. So, for example, forestry has some special algorithms to calculate different attributes from trees or infer tree type. So that's very easy to be built into the software at the moment. So we're looking for different use cases and different ideas for features that the different industries are interested in.
Yes, and I also get some questions about the coordinates convert function. We have a very strong coordinate convert system inside our software. And for example, if you open a local point cloud data, if you scan with the RTK, and you will get the base map, and you get the coordinate system, and we will have the CRS convert function, have a multiple choice. For example, we have the built-in coordinate system is around 1,000 coordinate system from different countries, and you can get a lot of details. It's automatically already inside. So a lot of customers, even they are not surveyors, they can easily find their own coordinate system here. It's already covered nearly all the countries, and you have all the special parameters. And if our customer have more idea about some local coordinate systems, then we can also input it, put them together. And also you are able to use EPSG code to identify the coordinate system, and it's really easy. You can search the EPSG code and view the detail and attach it and run the coordinate transfer. And also we support the grid. You can click add grid. You can add a lot of built-in grid for a lot of countries. So it's really easy. A lot of grid is not an issue because you already get all the grid inside the software. It's really convenient. So you can easily click and attach the grid to calculate, and you can do the test convert. You're able to do the preview to preview the conversion if it's okay or not before you run the whole test. And for this software, for our idea, it will match with all the customers' needs. For example, if you are not a surveyor, some customer worry about it's hard to learn, but we will have a help center here. You can get all the information, how it works, and the problem you want to ask, and for every function, you will able to get help here. You get all the information and how it works. It will tell you the software how to run. It's like a small user manual. So just takes 3 minutes to read the function, then you can understand everything. No need ask for anyone how it works and a lot of questions. So this is a really user-friendly. We believe is really user-friendly and also makes the customer can do a quick understand all the function. Even you are not a surveyor, even for anyone can use this function. So we believe we want to make the software as a more unique software, is more function and very easy to use, very user friendly. And for these small details, you can also find a lot of small questions here. You just touch the mark on the screen, then it will display how it works and tell you what is this function for. Yeah, it's really user friendly. All right. Well, what do you think, Luis?
I'm going through the questions in the chat. There's a lot of questions there, and if we don't have time to get through everything, you can always send us a question direct. But there's a question there about 3D GS that I think you can answer. If it's viewing or can we generate splats?
Currently, inside the MVPStudio is viewing 3D.js is to view the result. We also have a solution to process 3D.js, and in the future we believe it's possible to build 3D.js process inside the software. Yeah.
Yes. And can we do point picking and measurement tools inside the splat?
Yes, you can do the point thickness measurement. We have the the functions to measure the thickness. We have a profile functions, and it's really easy.
But for the splat viewer also, yes.
For point cloud, yeah.
Another question there on the machine learning and tracing. Yeah, that's what it's based on. And there are different models there. So one of them for based on colorization and intensity, and then the other one based on geometry and features. There's another question here. If the last file is coming in from another brand, does the AI line tracing still work well? Yes. So it basically depends on the quality of the point cloud, but it can work on any point cloud.
Yeah, we have a very good
Go ahead.
profile function here, as I showed here.
One question asks if we have plans to do photogrammetric processing. I don't think that's something that we've done before. I'm not sure if it's on the pipeline for this software, which is focused on point clouds.
Yeah, this data is from MVPS1 I display here. And we also have the fly-through functions to do fly-through trajectory.
There was one question previously, I'm not sure if it was answered. The chat is getting too big. And it was about that fly-through. I think if it can be saved or exported.
Maybe in the future we will add this function. Currently, just the display and fly through with your trajectory during the scan. And if you want to generate the video, currently you can use the video recording functions to record the video.
Yeah, but not rendered video yet.
Yeah.
One question here also, can we trace the elevations and export them into CAD? So I'm assuming by trace is the automatic trace. That won't work with the line trace, but you can manually trace the elevations or manually define points. You can bring in DXFs and overlay them on the point cloud. You can generate points, lines, areas, and export them as DXFs. So it's basically anything that you can trace in 3D can be exported into CAD. And can we add the dark mode? I think that, yeah, that's a good suggestion. It's very bright.
Good idea. Yeah, good idea.
Area, yeah. Peter, can you show there calculating the area of a vertical wall?
Of a vertical wall to do what kind of calculate?
Area. So area for a vertical plane.
Okay. Currently this area calculation is for plane. It's
Okay,
for
only for
horizontal. Yeah.
Okay.
That's a vertical calculate. If you have a need of a vertical area calculate, we also can do. We can make it as a new function in the future. That's the area calculate, and you can easily measure the distance. You can easily measure the height. For example, measure the height of the building. Yeah, just select the top point and select the end point. It automatically detects the height and do the measurement, and it gets the information you want. And we also have some, if you want to get the point extract from the point cloud, we also have the capture functions, helps you to capture a point one by one. It's just like you have a receiver, you pick the point in the field, and allows you to export as a CSV file with all the coordinates. This is a very user-friendly function and also very easy to use. For example, before I use GNSS receiver, I need to take hours to do the calculate to record all the points like this, but in the point cloud, it's really fast. And you can quickly get the result. And I see a lot of questions here, and Luis also answer the question in the chat. If you have any other questions for the software or for our hardware, MVPS1, MVPS2, MVP 400, MVP 100, we have 4 different hardware scanner. And for any other questions, we can all answer, and you can just send the questions by email, or if we have a group, you can send in the WhatsApp group. You can add our sales team, and we have a very good technical support team to contact you, and we can give you the free trial. Yeah, we can give anyone the free trial license. You just send us the information, send us the requirement. We will give you the free trial, and you can have we're welcome for any feedbacks from our customer, and you have any idea also can talk with me. Yeah.
Yes. So I think yes, we're getting close to the end of the session, and I'm sure we'll have some follow-up discussions with a lot of the audience here. We will send out the recording of the webinar, the files that were used in the demonstration, and any questions you can keep in touch with us, and Peter will be happy to add all of the features that you asked for. Is that right, Peter?
Yes, right. Yes. All the feature you ask for, maybe it's possible in next version.
That's good. Very good. All right, everyone, thank you for joining us. This was a very big session. It was surprising. It was really good, exciting, and I hope we'll be in touch soon. Thanks, everyone, for coming.
Yeah, thank you.